This video demonstrates the use and purpose of the Aeroflex 3920 digital radio test set limits function. To get the most out of this video, we recommend viewing these videos beforehand. In this test setup, the broadband power meter and frequency offset meter are selected for display on the meter's tile. The radio transmitter is connected to the TR connector, and the analyzer's RF frequency is tuned to the radio's transmit frequency. We're ready to key the radio. The radio is keyed, and the instrument is measuring the RF power and transmitter frequency offset. The numerical and bar graph data tell us that the transmitter power is 998.62 milliwatts and the frequency offset is -24 Hz. These readings may or may not be within specification of the radio. Determining if a measurement is exceeding a value or if it is between an upper limit and a lower limit can be accomplished efficiently through the use of the limits function. The use of limits is particularly useful for performing a quick check of a radio's functions. In this example, limits are set up for a number of different parametric measurements of the radio. Green indicates a passing value. When this radio is keyed, it is immediately obvious that the radio is passing all of the parameters of its test. When the radio is keyed, one can tell at a single glance that the radio has passed frequency offset, power, squelch tone frequency, squelch tone deviation, and squelch tone modulation distortion. Limits are set up using the configuration tiles. In the analog duplex system, there are 5 configuration tiles dedicated to setting up limits. The RF limits configuration tile is used to set up the limits for parametric RF measurements such as frequency and power. The mod limits configuration tile is used to set up limits for FM and AM modulation measurements. The mod noise limits configuration tile is used to set up limits for demodulated noise and frequency measurements. These limits would apply to transmitter distortion, SINAD, signal to noise, and hum and noise measurements. Note that the demod frequency limit is also set on this tile. The AF limits configuration tile is used to set up limits for audio noise, level, and frequency measurements. These limits would apply to receiver distortion, SINAD, signal to noise, and hum and noise measurements. This tile is also used to set frequency and level limits to audio signals applied to the instrument. The DMM limits configuration tile is used to set up limits for the digital multimeter AC and DC volts and current measurements, as well as ohmmeter measurements. As an example of setting up and using limits, we'll set a transmitter frequency offset limit to our radio. Let's say that our radio can be no further than 30 Hz off frequency from its transmitter channel frequency. So we enter 30 Hz as our frequency offset limit. In order for the limit to become active, it must be enabled. Now we'll return to the test tile and key the radio. Note that the frequency offset meter is displayed in green. Green indicates that the reading has not exceeded the limit of 30 Hz. Now let's assume the radio has a tighter specification of 18 Hz frequency offset. Now, when the radio is keyed, the frequency offset is displayed as red. We know immediately that 24 Hz frequency offset exceeds the 18 Hz specification of the test. Now we'll apply limits to the broadband power meter. Note that the power meter has two limits, an upper limit and a lower limit. The nature of a measurement determines whether an upper limit, lower limit, or both are required. For example, the frequency offset meter does not require a lower limit. That measurement is used to measure how high the offset is. The radio can never be too close to its transmitter frequency, so a lower limit is not required. In this example, we'll set the limits so that the radio cannot exceed 2 watts and cannot be lower than 500 milliwatts. When the radio is keyed, we immediately know the radio is within specification. 996 milliwatts is below 2 watts and above 500 milliwatts. Let's assume the power can be no higher than 2 watts, but no lower than 1.5 watts. The color blue indicates that a measurement has failed to meet its lower limit. We know at a glance the transmitter is failing its power specification and that it is too low. Now let's assume the power can be no higher than 900 milliwatts and no lower than 500 milliwatts. We know at a glance that the transmitter is failing its power specification and that it is too high. It's obvious there are numerous limit values to set. In fact, setting up the limits each time a new radio is tested would take more time than the actual test. However, if the limits are stored as a setup, recalling the setup takes very little time. In this example, the settings to test a particular radio model's squelch tone parameters are stored as a setup. After the setting is recalled, the radio only needs to be keyed to perform the test. As demonstrated in this video, taking advantage of limits and stored setups can greatly enhance productivity and efficiency in the radio test environment.